for Etherpad note takers? Anybody need this is the first thing we have to do, so let's. I know we have someone driving, so Russ Housley can't do it. Somebody else who's not driving, who hasn't done it.
Did you put a website together, Ned?
I did. There's a link on the agenda, the Etherpad.
I might start calling out names.
Hi, yeah, this is Rich. I'll take notes in the Etherpad. How's that?
That's great.
Thanks, Rich.
That would be awesome.
One more to help out.
How about Guy or Lawrence?
Lawrence is going to be talking.
Lawrence will be talking.
I will help Rich after I talk.
That's Michael?
Okay, I can help out.
Thank you.
Michael's talking. Ned. Okay, so we have note takers. So our agenda today is mostly Lawrence, but we do have 5 minutes for architectural update and status, as well as I think we're going to have a few minutes on use cases.
Quick interrupt. Which link for the Etherpad? Etherpad /p/
notes-IETF-rats-vi-2020-02-05. It's on the agenda. I don't know if you can see the screen. I think I'm displaying it.
Oh, yeah. Okay, got it. Thanks.
Yeah. Okay, so any other agenda items we need to cover today? We have a full agenda, so. All right, so Michael, how about you start off with update.
Did I take the ball for displaying there?
Yeah, you took the ball.
Okay. Rich. Okay.
Ned, can you put the Etherpad link in the chat room, please?
Sure. I did that actually already.
Oh, thanks.
So briefly about the design team. We posted a new document yesterday. The diffs should be quite useful. Who has it been? And I feel I missed one or two people on this list. Dave Taylor, Frank, William, Hank, Thomas, Monty, Ned, Eric, and I'm sure I missed one person here.
Yourself.
Myself. That's true. Myself is in this list, and I think there's somebody else that I've missed that's probably really loud, and I forgot about them because they're so loud. So we've been meeting Tuesdays at 10 a.m. EST. So yesterday we had a meeting. We had about 8 meetings since IETF 106. 8 open issues still, 2 closed. We had 23 pull requests, 2 are still open. So most of the meeting has been spent going through the suggested text someone has proposed, and a lot of heavy bashing and a lot of going around, I wouldn't say in useless circles, but sometimes it seems like circles about precise meanings of words, and I think that that's a little bit what that's what our goal is, to nail things down. I feel that we're making a lot of progress, and we have, I think, a fairly good consensus process going forward. So there's the URL. I could paste it into the chat even. That has the diff. Major things since version 00, which was a very skeleton, is we've added a composite attester concept. So this is the idea that you have either a chassis with a bunch of line cards you want to attest to, or in some cases you may have an Android or other mobile device that has some additional processors or even enclaves or something like this that will attest around for each other. We filled in a lot of the conceptual messages. Passport background check model, this kind of thing. And we added a bunch of diagrams. We're currently discussing, third slide still to do. We still have a fair bit of discussion of the terminology. There may be some additional additions that we make, but we're trying to keep it fairly tight. We have an introduction that we need to write, and it probably would have taken text from one of the other drafts that was proposed. The working group still needs to decide if they want any use cases in this document. And if so, do you want some of them, all of them, how many, at what level of detail? So we haven't had any use case documents. We have some text coming, which is on the, essentially it's been called the layered approach to attestation, and this should be recognizable to many who are familiar with Secure Boot and Trusted Boot, and how that kind of process works. And so that text will probably slide in the next week or two. Based upon the rate that we're going, I expect us to have a document that could be working group last called by IETF, or perhaps just finishing one or two things at IETF. And that's about it. I guess I'll stop here for questions about what's going on.
I think this is really good progress.
Mike, this is Russ Housley. One of the things that in hallway conversations I hear people saying is, we keep talking about how suit, TEEP, and RATs all tie together. Is one of the use cases going to explain that?
Yeah, so we already have, in the use case document, we already have that as a use case. We also have the fact that that the TEEP use case is in fact a hybrid of background and passport check mechanism or topologies. So that's actually one of the driving factors for some of the documents there. As to how does suit precisely connect into it, I don't think that we have anything specific to say at this point, but I guess if there was, and I'm not sure that there is a direct connection, I think it's a connection through TEEP as a use case for TEEP, that suit is a root use case for TEEP, and that TEEP is a use case for RAT. So I don't think we have a direct connection to suit, unless I don't understand it.
We had some conversation. We had a bunch of conversation about the suit manifest structure and how it may or may not relate to the thing we're calling endorsement.
So this is Dave. I was just going to agree with Michael that chances are that relationship to suit will just be in the TEEP architecture document that may not appear directly in the RATS architecture document.
Maybe it's as simple as saying. Sorry. Maybe it's as simple as saying that
We can't hear you.
Yeah, you're breaking up.
Sorry, I'll try again. Maybe it's as simple. Now I'm here. Hello?
Go ahead, Russ.
Yep, go.
Right. Maybe it's as simple as saying that the software needs to come from an authenticated source.
But the RATS architecture document doesn't talk about sending software. The TEEP architecture document does. The use case.
I understand that.
In RATS, because I think you're commenting on the Michael's presentation, which you may not be able to see right now, but he said, the working group needs to decide if they want use cases in the architecture document. If so, all of them, how many, what level of detail. I think you're answering that you certainly want the TEEP use case covered in there, and you're asking about the relationship to suit, and should that be in the level of detail that's in the RATS architecture document?
It's just I hear a lot of people talking about how the three fit together, and so it's important that the architecture at least provide a hint.
Certainly the TEEP architecture does. I think the question here is whether the RATS architecture document needs to go into the details of the TEEP architecture, TEEP use case, or to leave that to the architecture document? I think that's the question.
So, and I think one thing needs to be clear if it's specified, because on the list, some were inferring that we could just use the suit manifest, but there are other manifests that are widely adopted for software update for larger systems. Like I can't see Dell adopting the suit manifest because we already have stuff we use that's well adopted elsewhere. Right, so, but we may want to do other things.
Exactly. So, but what you do is either have a trustworthy source to describe those packages, or you can do remediation with them. And remediation is one of the goals Red is working towards too, but is not having its scope. So the remediation action could be this sentence that we have somewhere in the introduction, maybe, or somewhere else near there, that says, and suit has some remediation capabilities due to updating complete bundles of software. The end.
So what I'm just saying is that suit is one option for a format
for example,
manifest, but there are other viable options that are well adopted that may be used as well. So
maybe a bow tie.
Okay,
We may
but
have
I
a bow
think
tie
both-
diagram.
Okay, I have to go back to the
a
diagram.
wrap
but
problem.
Go ahead, Nancy.
Yeah, I was going to say, I think what Russ is suggesting is, from an architecture, just make mention how the three interplay as a potential use case, not necessarily that becomes the mandatory, right? And Kathleen, that should
Exactly.
serve
Yes.
your purpose.
Exactly right.
yes. Yeah, and I understood that from Russ as well. I just wanted to clarify the other point so that people saw a bigger picture that's outside of the IETF.
Okay.
Okay.
Done? Going.
Yeah, wait, sorry, it was on mute.
Was there a comment?
Yes, sorry, this is Rich. Mike said, oh, we'll be done, and then we can go to working group last call, and I think that's inappropriate to go right from a design team that's been working for weeks directly to last call. It should sit in the working group for some number of weeks.
That is correct. So,
I agree with you. We're trying to come back to the working group regularly so that nothing is a surprise.
Good.
But I guess we've also been told to get it done. So, if the working group chairs want to have a 6-week last call or whatever they want to do, it's whatever is appropriate. It's up to you. Shout louder, I guess.
okay, so the question, Michael, is when does the team believe they can have a draft ready? You said around the time of IETF 107, but it would be good if you had something at least a week or two, preferably 2 or more, which is about now, to give the reviewers or the participants a chance to review so that we could have the question at the IETF 107, whether the group believes this is...
I believe the draft cutoff date is March 9th.
Yeah.
And so that's in 4 weeks about. And we have a hackathon in 2 weeks. I imagine that for those of us who are there, and we will make some significant in-person progress on any outstanding issues that we have. So what I see is that the draft will be, call it feature complete, in about a week. And then that leaves us about 2 weeks for debugging if you want to take my software model. At this point, it's not feature complete. We have some questions about whether we should have certain features or not. And so we're very much looking for the working group's feedback on that. And I guess we'll make a decision if we don't clearly hear an answer. And I will actually post some emails to start some discussions on some of these questions, but don't feel you have to wait for me.
Okay, we're kind of into Lawrence's time.
I'm done.
Okay. Any other comments? If not, we're going to switch over to Lawrence.
Yeah, I'd say just post the document, Michael, and then we'll move from there. Don't worry about the procedures yet.
All right, I've made an attempt to start sharing. Can you hear and see?
Yes.
Okay, all right, let me jump right into it here. Okay, so there's been, one of the open issues here was, well, sorry, back up a minute. So my hope here is to get permission to merge a bunch of pull requests that are outstanding and produce a next draft of the RAS document. I'm hoping that the pull requests, I don't think they have to be perfect at this point, but I think we need to get some of this into because we're not anywhere close to last call, but I think it would be really beneficial to get some of these into a published draft for people to look at. So that's my goal here. We don't have to close the issues. We can just we want to make sure I'm upfront with the process here. So, okay. So on UID size discussion, I think it was Montreal when someone pointed out I wasn't paying attention to the birthday problem. So now I am, and have done some math and some thinking about how big UEIDs should be. This is for the UEID that is based on a random number, not the UEID that's based on like an IMEI or any of these other schemes. So first I want to point out that UEID sizing is not the same as for IP addresses because they can never be reassigned or reused over time and space. The devices might not be IP connected. And we expect there to be very large databases of IoT devices in IoT backends. So I considered three use cases, or three scenarios. One where we have 10 billion people, each person has 100 devices, and that's because this might be light bulbs and motors and parts of cars and parts of refrigerators, parts of public infrastructure like traffic lights, and parts of the factory that they work at or the office they work at, and so on. So 100 actually is maybe small in that way.
100 over their lifespan? Or concurrently?
I didn't think about that.
If it can't be reassigned or reused, that would be lifespan.
Yeah.
Seems small.
Yeah. So anyways, we get a database size there of 1 trillion. There's also an assumption based on that the database would only be 1/10 of the devices, the largest database. So that scenario seems highly realistic, and we're fully expecting it to happen. 128 bits is enough for that. The next scenario, okay, we bumped that to 100,000 devices per person. Now we've got a database of 1 quadrillion and then 120 bits seems marginal for that. This is kind of the edge of what I think we could, from what we can imagine today. Then the third case where we've upped it to 100 billion people, and maybe we're, I don't know, tagging all mammals or something, and 1 million devices per person. Now that seems all speculative. Maybe we're dealing with nanobots or something like that. Anyways, that's just to test the bounds there. So another use case there. So that would need 192 bits at least.
Is that including the birthday paradox or not?
Yes. So there's an appendix. I'll show you that calculation in a minute, but I think our options are we can say it's 128 bits, which is kind of what like GUIDs do, and we never expand to that beyond that. We can say it's 128 bits now, but you should anybody that's receiving that you should allow for 256 bits, or we can just go straight to 256 bits. So the center of gravity seems to be on around option 2. So let me show you some of the background for the calculation here. Let's see. So the first table there is how I got the number of entries in the database. So a little more detail there. So 10 billion people, 100 devices per person. Each device has 10 subsystems. The largest database is only 10% of the entire population. So these two columns here, the subsystems in proportion basically cancel out. So then I did the probability calculation based on the birthday attack for one database of those. So 2 times 10 to the minus 15 for 128 bits and a trillion records. That seems okay. 10 to the minus 9 for quadrillion seems marginal, and 1 in 10,000, I think, or 1 in 50,000 for 10 quadrillion is clearly a problem. 192 bits is good for all of them. Then I assumed that the database, 10% of the database changes per year to try and calculate the time between a collision. That's a very pessimistic view. So, these numbers are very pessimistic. You might say, well, okay, you calculated it at 8 seconds, but that's really a worst case, so it's maybe more like 10 days or something like that. But anyway, that was where I was really trying to pin this down to a number for this active database.
I don't understand the database reference. Are you saying that someone has to maintain a database and check for collisions, or that they're probabilistically not going to collide? I'm
saying the situation where collisions are going to occur are in some database somebody is maintaining. I'm assuming that somebody will be maintaining a database, one of these IoT service providers.
Mm-hmm. Not necessarily for every device you're saying, but for all my devices or for all whatever. So
for 10% of known devices. The largest database will cover 10% of all the devices out there.
So I want to ask about the birthday problem and the database, and I don't know if this is arguing that number one is an option more than you thought it was or what, but the question is, you're assuming that a collision happens whenever the ID is the same. What I'm going to ask is that really the collision, or is the collision only if the ID is the same and it is signed by the same entity?
The GUIDs are supposed to be the UUIDs are supposed to be entirely independent of any other parameter, such that you can rely on them solely for uniqueness.
I'm asking, why is that the case?
Because it's the simplest and cleanest design.
I'm going to question that, because I would say, let's say that you have a design that can easily use GUID. So you're stuck in the 128 bits, right? And so the way that you deal with the collisions is you say, I'm going to only consider it to be an exact match if the GUID matches and the signer key matches. What I'm wondering is, does that mean that 128 bits is more than sufficient for now and forever? That's my question.
Or do I need to use this ID in my local database to figure out who the valid signers are?
I had not considered that option.
I'm just asking. I don't know if it's a good idea or not, but I'm throwing it out there for people to think about. Like I can tell Michael's thinking about it. Thank you.
My thought was that the UEIDs should be as independent as possible, and
right. So you gave an analogy to IP addresses before, just to explain how they're different, right? And so in the IP addresses, you can have IP addresses that collide as long as they're in a different context, like linked local addresses and so on. And so if you use that analogy that says, do you care if the IDs collide if they're in a different context? Maybe the context is the signer key. That's just what you made me think about.
Right. The question is around, is there a use case for an anonymous, unauthenticated UEIDs? And if there is, then you can't assume that there's a key signing them.
Yeah, it just seems we get into messy dependency now that we have to think about how uniqueness has to be based on something else or some other system. And
Well, no, another way to think of it is the EUID has got a local part and a signed part, and the global EUID, if you will, is the combination of the local part and, say, a hash of the EUID, and for anonymous, you just make the hash value be 0.
Well, that's a great point. If we think about it that way, then you'd say your full global EUID, just to use your term, is maybe it's, I don't know, 256 bits or something like that, of which 128 bits is a GUID, and the other 128 bits or whatever is a hash of the signing key.
Exactly.
Very interesting way to think about it. Yeah, thank you.
So there is no specification how the UEIDs are created, and it's entirely, they should have the appropriate amount of entropy in them. But I mean, you could be compliant probably with the EUID spec by doing that, just taking the hash of the signing key and a GUID and hashing those together to produce 128 bits. That's probably compliant with what is being asked of EUIDs.
So the reason that I'm thinking that I kind of like that suggestion is because I expect you're going to put an ID into an actual claim. And so even for constrained devices, these numbers are going to appear in the claim sets. And if you say you only have to encode 128 bits, your claim sets get much smaller, right? And so you can deal with constrained devices much better in, say, option 1 than in option 3, right? And so if you do it the way that we were just talking about, then you only did 128 bits in there because your signing key is already in there elsewhere.
Exactly.
Yeah, I don't like that idea.
For constrained devices, I think it's better than option 2.
32, you can't afford 32 bytes?
If you could, you wouldn't be arguing that, gosh, I need CBOR.
Yeah, for
other
IoT,
questions,
that
are they
might be
repeated? Are they repeated in different claims?
If you look up at the top of the slide, it says subsystems per device, and so that means even within your own device, the average is here is you'd be repeating it 10 times.
Yeah,
different
that's what I thought. That's what I thought, yeah.
Right.
It doesn't mean they have the same signing key.
But the signing key's already around. It's already got to be indicated somehow.
So those are 10 independent EATs that may have that should have no relationship to each other. That's not a reduction possibility.
I don't agree with that because those may be subsystems in the composite evidence or subsystems in the layered one where they do have a relationship between them. So 10 layers of some sort, or a tree of things of 3 layers with various leaves, and so it's not just a chain; it's a tree. So there can absolutely be a relationship between them. But you're right; there can be keys that are different. But Michael's right that you got to put the keys in that. In the evidence anyway in different claim sets.
But the explanation for anonymous was that there's an assumption of reserving 128 bits for the empty key that has to be represented somehow. That ends up, and you sort of end up in the 256-bit space somehow anyway.
So it's encoded in CBOR, so we actually have a length that we can have an empty string with an empty key. Like we could say there's a thing and it's just not here.
So based on the interesting the suggestions given so far, I'm going to argue for option 1.
Yeah, with respect to the
variation of option 1, where option 1 is how many bits are actually encoded in the claim set, even though what you're using for matching is, say, 256.
You're arguing for a UEID that's defined in a very different way.
Correct. Yes.
And so, I think we're probably going to have to take this to the list for some back and forth discussion because the clear intent of a UEID here was it is the sole thing you need to uniquely identify the device in the world. And if you want that identification to be based on more than one claim, some combination of claims or characteristics or pieces of the EAT, then I've got to go back to the drawing board on this.
So I think it's actually more like I don't have the slide, option 3, where it's 128 or 256, because if you have the context, then you can use, quote unquote, the short form.
Right, but we have to specify how that context works, right?
Yeah, but it may just be as simple as if you have the key available, then you can, and you're concerned, you can use you can construct the long form, which is the digest of the public key that signed the entity that contains the EUID.
There's some intuition in the use case, which is devices per person. Person is the key holder, and devices are the UEIDs that are owned by that person. It's sort of already broken up into two numbers.
It's just to give a size of the database. It serves no other purpose.
I understand. It's just, but it's some intuition. I mean, if you go for 256, then you're basically saying there's still the owner, the person, and their key, which is going to disambiguate from some other owner.
Yeah, I do think it's...
So there's a fork here. You guys are... in the intent, the very clear intent of UEID is it is the sole claim that identifies the device uniquely. And what I'm hearing everybody say is, no, we don't want that. We want the uniqueness of the device to be identified by a combination of claims, and some sort of a GUID thing that's not a UEID is one of them.
I think they're just trying
saying
to
that for constrained IoT devices, smaller number of bits is better, especially if the problem is purely speculative. Then so like I'm looking at your screen right now, scenario likelihood speculative, right? Putting definitive cost in the short term on tiny devices for things that are purely speculative may not be a good trade-off. That's what I'm pushing back on.
So I was in the option 3 camp before because I thought 256 was affordable and simple enough. Listening to Dave's argument, I'm now in option 2, and I want to point out that in a CBOR structure, at least, relatively easy to do 128 bits or 256 or some prime number in between if you prefer. And that the complexity in dealing with this is really on the receiver, which generally not as constrained. So option 2, that 128 is the minimum, but that we should allow for more, seems like probably reasonable to me.
So Michael, can you elaborate on your probably? So if you have a constrained device that is I guess I'm going to phrase it as a relying party. So let's say you have a light bulb that you want to turn on or turn off, or perhaps a better example would be I have a door lock, and I only want to allow it to be locked or unlocked by something that's attested.
Well,
so the question, because I thought Lawrence originally said that you need to put in on the receiver side now things that might happen way out in the future. And so what would you do in your door lock or other constrained device?
Well, I'm not sure that I accept your use case to begin with, because I'm not sure that I'm going to do an attestation every time I turn the light on and off or unlock or unlock the door. I think it's going to happen at some commissioning time, and so I think there's something more complicated going on there.
No, sorry. Let me rephrase my use case. I only want to allow it to be unlocked by a remote party who's been attested. Now, the other way around that is to say, well, the remote party has to go through some verifier, and as long as it comes in signed by the verifier's key, I never pay attention to the UEID of any sender. Right? It's not even in the attestation result.
I would tend to think that that's actually what's going to happen.
But that's the passport model that I'm describing.
Yeah, fair enough.
Go on.
Okay. So if you want to do it the other way around, then I accept that there may be a cost in the future, but that's why I'm saying I think we can live with 128, but I'm pessimistic about about this, and so I'm saying like, well, okay, so if we live with 128, that means we don't pay any network cost for the extra bytes now, but we potentially pay for a code space requirement to be able to process it in the future, right? So that's where it comes down to, I think, right?
I think that's a good point.
Okay, and my observation is that code space crunches we're mostly over. We're at the, you can have a couple megabytes of code in most fairly tiny devices now. It's not 64K anymore, and so I don't think that is going to be such a big deal for that. Bootloaders and other stuff that Suits dealt with, you know what? There's other code space constraints, but I don't know that matters here.
So my understanding of
I'd like to make an observation that I think the two sides of this are talking past each other in one respect. One of you is talking about a thing to uniquely identify the device, and another seems to be talking about uniquely identifying the claim or the attestation. So if ownership of the device changes, if ownership of the device changes, do you expect a different identifier?
No. Well, what do you mean by ownership?
Okay.
Second, why do you say no? Because there are privacy issues if you say no.
It's all over this thing.
I'm going to say yes for exactly the same reason as people argue that you should change the MAC address of a device when it changes ownership. There are arguments about that as privacy.
Yeah,
I think it will change. I think it will become
the draft really very thoroughly.
I think ownership transfer is an important point that needs to be covered in the discussion, and I think there are valid arguments as to why things should change. But the main point is this needs to be discussed. Great point for us.
Okay, so I think we need to regroup on this. I'm basically going to plan a much more very detailed step-by-step review of what's in the draft for the next interim to try and get to the bottom of this. I probably will write an alternative version of the pull request where you save 16 bytes by combining some sort of an ID, which I will not call a UEID, with a signature key identifier, and try and deal with the complexity of that.
I'm still thinking about Michael's suggestion. I found Michael's suggestion a great way to think about it, and so far I can't find any faults in Michael's argument. So thank you. That would be useful to discuss as well.
So let me understand. One thing I did not understand wasn't clear to me one way or the other from various people's points was whether this set of bits is standalone as the identifier or it is in combination with other claims. Was Michael's suggestion standalone or in combination with other claims?
Standalone.
Standalone.
Standalone. What he was suggesting was that when you generate UIDs in the short term, meaning for now, for the next couple of years, the high 128 bits is always 0, so when you encode it in CBOR, it gets to be compact as much as a 128-bit number would be. You don't spread it out across the full 56 bits.
So byte string.
So I got that right, Michael, right? But for right now, you generate 128-bit.
I didn't know I exactly said that, but I guess that's what option 2 is. Yeah, you do 128 bits now, and effectively the upper bits are 0. I hadn't thought whether they're the upper or the lower bits, but yes, okay, upper bits are 0s, and so yes, it's a byte stream. How else would it be encoded in CBOR? I have no idea, other than as a byte stream. So, I guess it could be encoded as an integer, but do we support 256-bit integers?
Same. It's a very big integer unsigned. It's the same size.
Yeah, it's the same thing. Doesn't matter, right? So that's that's how I would think it is. And so look, as I said, if we want to have 192, I think we shouldn't because that's a code-based issue for dealing with on the receiver. We should have 128 or 256, and that's it. And anything else is an error. And that's good enough to test with. Like you can test those two cases, and if you need to do that.
Yeah. So if you use a GUID generator now and you fill it into a 256-bit field and C4 compresses it into 128 bits, then that's just as good at the bandwidth level, not the code space level, but the bandwidth level is the same as option 1.
If a UEID is something that a hardware manufacturer has to burn into fuses or something, then that adds cost if you don't accommodate smaller values. And if you're zeros, that's a lot of waste of fuses.
You don't have to put the zeros in, right? So if you're going to burn 128 and you've made that decision to 128, then I think you're just fine. And I going forward, we may have a point that says, you know what, we're switching to 256s, and there'll be a mix for a couple decades, and whatever, fuses become very cheap or something. I don't know. Maybe we'll never need them.
So I think, Michael, you're just saying you want option 2, which is what the current text says, and
that's what I did say. I did say I want option 2. I'm
so
convinced for option 2.
Yeah, so the current text is fine. Maybe we want to disallow values between 128 and 256 bits, so it's either one or the other. That's fine with me. I don't know either way, but
well, there's going to be cost associated with whatever you pick. So if you're forcing 128 or 256, then if the use case only requires 192, then you're sort of adding unnecessary cost.
This is Hank. If you want to have incremental steps between 128 bits and 32 bytes, and then heading to it, just make it byte intervals, not single bits. That would be like difficult, I assume. Just make it at 8 bit steps, and then it's okay. Really, there's no big deal to it, I think.
I mean, I would expect the implementer to burn a 128-bit secret into the device, use a KDF to derive multiple keys and IDs from that. That's the smart way to do that. So it shouldn't increase the number of bits. This is probably smart implementers will not need to add any more fuses to implement UEID like this.
Are you saying to get to 256, you only need to start with 128?
Oh, no. No, I'd be
I was going to say that doesn't make sense.
billionaire if I could do that. Okay, so sounds like it's okay to merge. Are we okay to merge that? Okay. All right. Doesn't mean it's stuck that way forever, but I'm going to take that as an okay to merge and move on here. Okay, so on to submods. This is a repeat slide from Singapore. Nothing new here. The reason I'm hitting submods again is I want to make sure there's enough understanding of what's in the current pull request and kind of get a permission to merge it. I don't think it's perfect, and I think it will need another go around, but I think getting it into a draft for more wide review and also getting all the CDDL fixed, it's kind of key to getting the CDDL fixed. Is a really useful thing. So I want to point out a few things here. Claims are not inherited. There's no inheritance between a module and a submodule. So like in this example I'm showing here with submods, the nonce is repeated for each submod, and like debug state would have to be repeated for each submod. So the no inheritance characteristic kind of is kind of in the keep it simple category. Maybe it will result in some larger tokens. I don't know, it sounds like that may be a concern, but if we do inheritance, then we have to start coming up with inheritance rules, and they seemed scary to me to try to come up with inheritance rules, especially like through some of these claims are complicated and hard enough to understand as they are. So that's one aspect of it. The other is this, so this new thing called attachment, a submodule attachment. It describes how a submodule is attached to the attester. So the values can be, it's enumerated, it's unspecified. Device internal means it's in the same device enclosure. PCB internal means it's on the same circuit board. Chip internal means it's on the same chip.
Is it mandatory? Specify?
I mean, I guess so. I didn't really think that through, but you could you would say unspecified if you don't know, or.
Well, I just say if it's optional, then unspecified is never going to be used.
Right. Either say it's mandatory and delete the unspecified value, or say that it is, sorry, the other way around. Either say it's mandatory and unspecified as a value, or say that it's optional and there's no such thing as unspecified.
Okay.
It's just absent.
Yeah, I would second the last option, and I wouldn't make suddenly a claim mandatory out of due to this here. This is not a reason to make something mandatory. So,
I agree.
Yeah, I agree.
And this presumes that there's a fixed set of possible ways to attach. I don't know if that's going to be reality.
This is a difficult balance.
How do you deal with evolution of hardware design to sort of make it reasonable to say something?
So what if something is, say, plugged in via USB cable? What does that make it?
Yeah, exactly. Or it's a chiplet design, not really internal.
It's a what kind of design?
The chiplet.
What's a chiplet?
Exactly.
Well, please. I mean, I'm asking actually.
It's just this is sort of new concept where you chop up the wafer into multiple pieces and you mix and match them to come up with something that is effectively a much larger wafer. But it's just made up of a bunch of small wafers glommed together.
Okay, so.
Well, point is, it's the technology is not fixed. It can change, and this is assuming it's fixed.
How would a chiplet differ in its connectivity to a chip, and does it need to be described? Because I guess the point is, going forward, we could have 10 different variations like that, and is it important? I see that the USB cable is much different than it's in the same chip in terms of. What
really matters is how flexible the configuration is, and I think that the point of having an attachment claim is to try and speak to the configurability of the part. In other words, can it change? But it's not really called out directly as that's what we're trying to say here. And the threat is that if it's changeable, then it could change, and we want to be able to recognize that it's a changeable thing or not a changeable thing.
Yeah, so because if it's not changeable, then you don't have to go and the freshness is less important. But, if it's a Formula One car and you change the tires every hour, then that's a different story.
Right. So rather than try to enumerate different hardware designs, it might make more sense to talk more to the semantic of what you're after that's relevant to trustworthiness. Is it mutable, changeable, whatever is the right term?
So I wasn't going after immutable here at all.
Yeah.
I was going after some sort of rough notion of how easy it is to attack. So that if you have an attester reporting on a target that's a little bit removed from the target, how reliable is that attestation about that target? Because this sort of goes to how easy it is for somebody to trick that attester.
But this doesn't really do that. I mean, let's say you have a USB cable attached submodule, but it's all inside of a great big locked cage with a foot of lead or something like that. It's still external to the device, but it's very difficult to physically access, as opposed to something that has an enclosure that is not locked down and is in a public location. Device internal might be even easier to attack than the device external.
Right. I understand how difficult this is, and this is an attempt. It seems we need to figure out what we're going to do here, because you do need to understand. I mean, the evaluator of a token needs to understand how well attached that target is to the attester.
So on your intent, Lawrence, I guess the question is, do you have anything that's a claim, not about the submodule, but about the attester itself? So let's assume that there's no submodules. How do you know if the device itself is attackable? Do you have anything that measures that?
No, that one you can't really do anyways, because that would be self-claiming. The only way you deal with that would be through some sort of reputational thing or a certification program, and you would have to ask some sort of a third party nowhere near the target, the attester, like, how good is this attester?
Yep. Well, the reason I'm asking is I was trying to figure out whether, whatever the answer is, if the same answer would also apply to submodules or not.
If it's a signed submodule, then if the submodule is an attester, then presumably there is a manufacturer's certificate about the attester, which is like the root of trust or whatever, that would describe what it is and how it's manufactured. And that's the same mechanism that we would describe in terms of the lead attester.
But the point is, how easy is it to attack is something that the manufacturer doesn't know. So how easy is it to attack has to do with where and how it's deployed and what the physical protections around it are.
Right. So the verifier has to make these kinds of decisions. It's the manufacturer can say what it is. This is how it was manufactured, but the verifier has to decide if that's attackable or not. And by creating a claim that's trying to capture those semantics, it's moving away from the verifier dealing with it to the implementer trying to specify it, but they don't know.
And this is delving into the endorsement domain, because this starts to sound like the endorsement of subcomponents.
It seems like it, yeah.
Yeah, okay.
So how would that endorsement of subcomponents work? How are you thinking?
The manufacturer says, this is how I built the thing. I don't know if it's attackable or not, but that's up to the verifier to decide. But here's how it's built.
So how does the manufacturer describe that?
He's going to describe it as it's this I'm this vendor, and it's got this model. It's this model and version of something.
I mean, he's going to write an essay of, like, in this router, the parts are pluggable in this way, and I use,
He's going to write a policy that says, for whatever reason, I trust or I don't trust this model of something. And so it's a little bit like, he's going to write an essay, but it's his policy, and how he arrives at the policy is his business.
The verifier. So based on that, you would just be removing this whole submod attachment claim.
Yeah.
And I mean, submod attachment is going to
Or
vary.
you change what the goal is, right? It's like, in terms of, rather than it trying to define how attackable something is, you try to focus on something that's a little less abstract.
Like what?
I would say it would try to focus on how enumerate how modifiable it is, or how flexible it is to how pluggable or not pluggable it is, or how probable or something like that. I don't know. If it isn't sort of straightforward and obvious, then maybe we don't need it for now. Add it later.
Okay. So let's put that one aside for a minute, and I'll show you the way I set up the submods here. So the submods is sort of it kind of appears as a claim in the token. I mean, there's one label for a map that contains all the submods. So I'm just saying, like 20 here is the label for for all the submods. So I'm showing 3 submods here. There's a name for each submod, and that is the label in the map. And each submod itself is a map that is basically contains sets of claims. If you're embedding an EAT token inside another EAT token, then instead of having a map here, you have the EAT token, and you can tell by looking at the CBOR type, CBOR tag, because this will be tagged to say it is either a CWT or an EAT, however we end up with that tagging. So you'll be able to tell by the type whether you're dealing with a nested EAT or a submod, an unsigned submod. So that's the way the proposal is currently written.
In terms of terminology, is submod always an unsigned thing? Is it EAT always a signed thing and a submod always an unsigned thing?
No. A submod is either signed or unsigned.
But a signed submod.
Hey guys, I just want to do a time check. We're at the top of the hour, so we can wrap up.
Okay. So it sounds like we don't have enough consensus to merge the submods thing, which is.
What I heard is that you had consensus on everything except for the connection or whatever the last one was called. And if you remove that, you can merge the rest and leave the other one still open.
Okay, if you're okay with that? All right, so I'm going to go for that, and I'm going to do some cleanup on the CDDL at the same time.
Okay.
Yeah, so if you just move the other one into a separate PR so we can continue discussing this attachment type and merge all the rest.
I'll do that, yes, okay. The other two topics were some more debug stuff and the sort of guidelines for claim creation, but we'll catch up with those next time. And so I'll be producing a draft with the submods and the UEID merged, the submods less the attachment type with those merged, and that'll probably be the draft that goes for IETF 107 in March.
Okay, that sounds good. I mean, I still encourage you to start the discussion over email.
Oh, sure.
Lawrence, the other ones, yeah.
Yeah, well, I'll try and push it into GitHub issues, but yeah.
Okay, sounds good.
All right, thank you.
Thanks, everyone.
Okay, bye.
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 Thank you.